Welcome to Lesson 37 using scientific notation. This should be review for all of us, so we're going to go quickly through this. Just as a review, we're going to look at a couple of examples here on the charts in your notes. So we're going to just write in the answers for 1.08 times 10 to the second power. If you were to multiply that on a calculator, it would come out to 108. 1.08 times 10 to the third power would come out to 1080, and the next one would come out to 10,800, and 1.08 times 10 to the fifth would come out to 108,000. And then moving on to the next table, now we're dealing with negative exponents for 10. So 1.08 times 10 to the negative 1 power would be 0.108. Times 10 to the negative second power would be 0.0108. 10 to the negative third power would be 0.00108. And times 10 to the negative fourth would be 0.000108. So go ahead and fill those in on your chart. Should be nice and quick. Now we're going to answer some questions about them. So looking at your notes, which direction does the decimal move when the exponent is positive? And the answer to that should be right. So if you were to look back at the first table when the exponents are positive here, then the exponent in 108 is moving to the right, so the number is getting bigger. So the exponent's moving to the right here. The next question, which direction does the decimal move when the exponent is negative? We'd be looking at these. And for these, the decimal is moving to the left to make the number smaller. So how many spaces do you move the decimal? Again, look back at your table here. And at the beginning here, for 10 to the second power, we come out with 108, which is 2 places to the right. And then the next one is 3 places to the right, where we have to add a 0. The next one is 4 places to the right, where you have to add 2 zeros to fill in those spaces. So you can see that there's a connection to the exponent's number and how many spaces the decimal moves. So the answer to that would be the same number as the exponent. The exponent of the 10, of course. And then just as a reminder, in scientific notation, how many digits must be before the decimal? If you go back to your notes again, you'll see there is only 1 digit in front of the decimal. And not a 0. It has to be a non-zero number. So the answer to that is 1. There must always be 1 digit, and it has to be non-zero, and it has to be positive. And that is always, always in scientific notation. Okay, so let's look at some examples here. 4,900,000, we're going to put this in scientific notation. So the first thing we need to do is find our decimal, which is at the end of the number, because this is a positive number. And then we're going to move our decimal and count 1, 2, 3, 4, 5, 6. To where there's now 1 digit in front of the decimal. So then we can write down the number that we have here. We have 4.9, and then all the zeros get left off, times 10, and we moved our decimal 1, 2, 3, 4, 5, 6 places, so that's 10 to the 6th power. Moving on to the next example, we're going to take our decimal and again move it 1, 2, 3, 4, 5, 6, 7 times this time to get 1 number that's non-zero in front of the decimal. So we'd have 9.3 times 10. And since we started with a small number, and to get back to that number, we would have to move to the left. Then it's going to be a negative exponent. And we moved it 1, 2, 3, 4, 5, 6, 7 times. So 10 to the negative 7th power. Okay, now our lesson today is reviewing also multiplying and dividing with scientific notation. So if you move to the next page of your notes, we're going to try one example with multiplying. So when you multiply scientific notation, two numbers in scientific notation, you can first multiply their decimal numbers and then multiply the exponents of 10. So 3.2 times 4.3 equals 13.76. And 10 to the 7th power times 10 to the 2nd power. Remember the exponent rule that when you're multiplying numbers with the same base, you add their exponents. So that's 10 to the 9th power. So if we take these and put them together, 13.76 times 10 to the 9th power, we have something that looks like scientific notation. However, it's not in scientific notation until we only have one number in front of the decimal. So we want to move our decimal over one more space so that we can have 1.376. And because we moved it to the left, so that's one more space, we're going to have to move it to the right eventually to get the answer. Then we're going to add 1 to our decimal, so it's 10 to the 10th power. Always go back and check your work to make sure that it makes sense. Okay, moving on to division as well. We can do the same thing, so we're going to divide 6.8 divided by 2.5, and that equals 2.72. And then we're going to divide the tens. Remember, the opposite of the multiplying by this numbers with the same base. You add when you're multiplying, so you subtract when you're dividing. Excuse me, I'm stumbling over my words. So we would have 5 minus 8, which equals negative 3. So we'd have a 10 to the negative 3rd power. And you can see there's one number, one digit in front of the decimal, so that's our final answer. The next example, we're dividing again and just comparing two different fractions using scientific notation. So we'll start with the first one. 8.3 divided by 5.7 is 1.46. And 4 minus 8, so we're subtracting the exponents, is negative 4. On the other side, 7.2 divided by 4.4 is 1.64. And 5 minus 9 is negative 4. So we have two decimals here times 10 to the negative 4th power. So if we were to convert these, we would move the decimal over 1, 2, 3, 4. I ran out of space there. So we would have 0.00146. And over here, if we moved it 1, 2, 3, 4 spaces, filled in the zeros, we would have 0.000164. And usually we put a 0 in front of the decimal just so that we're not confused. I ran out of space on that one, but now since they both are in the same place value here, we need to just compare their numbers. So 146 to 164. 164 is greater, so this decimal is greater. Okay, moving on to the last example, we have the speed of light is meters per second. So we have a rate that equals distance over time, meters per second. If Venus is 1.08 times 10 to the 5th meters from the sun, so we know the distance, how many seconds does it take light to reach Venus from the sun? So we're looking for the time, so we need to rearrange our equation here so that its time equals something with rate and distance. So if we multiply by t on both sides, we'd have TR equals D, because those would cancel. And then we would need to divide by R to get T by itself. So T is equal to the distance divided by the rate. So now we're just going to plug in what we know. We know the distance is 1.08 times 10 to the 5th. And we know that the rate is 3 times 10 to the 8th. So we're going to divide 1.08 divided by 3, which equals 0.36. If you do that on a calculator. And 10 to the 5th divided by 10 to the 8th, we're going to subtract 5 minus 8, which is -3. Now we know we can't have a 0 in front of the decimal. It has to be a non-zero number. So we do need to move our decimal to the right one space so that we have 3.6 times 10 to the -4th. And that would be seconds for labeling with our unit. And that is the lesson. Thank you for listening and taking notes.